So we're going to use Pascal's triangle to expand the quantity a minus b cubed. All right? Step 1, identify the exponent, cubed, or 3, and then circle the corresponding row in Pascal's triangle that goes with that exponent. If this would have been squared, we would have used this row. If it would have been to the third, we're using this. If it would have been to the fourth power, we would use this row. If it would have been to the fifth power, we would use this row. So the row in Pascal's triangle always corresponds to the exponent that you're raising this binomial to. Good? Once you've identified that row, write down those coefficients from left to right and kind of keep them nice and spread out. So we're going to use 1, 3, 3, 1. That's step 1. Step 2. Begin on the far left term with a to whatever this exponent is, cubed. So on the far left, you're going to start with a cubed. Move to the next term as a squared. Next term, a. Then a is gone. And when a is gone, that's when b shows up as cubed. Go back to the left, b squared, b to the 1, b is now gone. So those are the 4 terms that are going to end up in the binomial expansion of a minus b cubed. If it was to the 4th, 5 terms would show up. If it was to the 7th, 8 terms would show up. You would always have 1 more term than the exponent that you're using. The last thing you need to check on, as long as there's no coefficient, and by coefficient I mean, do we have a 2a? No. Do we have a 3b? No. So we're going to skip a step in this one. Look at the next example to see what happens when you do have a coefficient. The final thing to do, however, is to look at the sign between the a and the b. If it was a plus sign, everything would be positive. Since it's not, every other term is negative. Since it's a minus b, it's a positive a cubed, negative 3ab a squared b, positive 3ab squared, and negative b cubed. If you don't like the ones, you can erase them, or you can leave them in. Okay, so just continuing on that, let's say it was a minus b to the 5th power. The first would be plus, then minus, then plus, then minus. Then you'd have another plus, then you'd have another minus. And they would continue to flip-flop back and forth from positive to negative until you run out of terms. So that completes it. That's the binomial expansion of a minus b cubed. If you'd like to check to see why it works, go ahead and work it out the long way by foiling and then distributing. That part's optional. You should see that you get the same answer.